Good evening, students. Today we are going to learn about basic proportionality theorem. What is basic proportionality theorem? How this theorem is applied for similarity of triangle. Those things we will learn. So what is similar triangle? Those things we have already learned. But this entire concept of similar theorem or similar triangle is based on this theorem called basic proportionality theorem. Proportionality means simply the ratio. Okay, basic means it is very basic to this ratio. So what is that? It is talking for a triangle. If you consider any triangle, say consider a triangle ABC. Okay, just you consider any kind of triangle. It need not be equilateral. If it appear to you equilateral, you may change it to any other kind. So let us consider a triangle ABC. Then you have to draw a line parallel to one of these sides, which is intersecting the other two sides. That is important. Means if we draw a line parallel to AC, let me draw like this. So it is intersecting the two other side of the triangle, means the side AB. We may consider this point as P, and the point of intersection of this line, which is drawn parallel to the side AC, the point of intersection over BCBQ. So it is talking for this one. If a line is drawn parallel to any one of the side of a triangle which is intersecting the other two sides, then it is found that the ratio of the two sides will always be the same. Means over the side AB, if you are taking BP by PB in the same ratio, you have to come for the other side, means BQ by QC. Okay, it is talking for this one. If you are taking the line parallel to AB, then it will intersect the side AC and BC, but the same ratio will also hold. Okay, but in this case we have to take the distance from the C to A, then C to B. So what is that? So regarding that, the theorem is like this. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, then the other two sides are divided in same ratio. It is this one. So how is that? So in this case, this we have to prove. So what is given? You are free to take any triangle ABC, take a line parallel to any one of the sides and intersecting the other two sides. We are free to choose a line parallel to AB or BC or AC. Like in above figure, I have taken a line parallel to AC. We are free to choose the line parallel to BC. So let me choose like this. This is our BC, the line parallel to BC. So according to this theorem, the line is parallel to BC, it is intersecting the other two sides. Let us call the point of intersection by this line over AB at P and the intersecting point over AC as Q. Then according to this theorem, the ratio that we can take with reference to this point P over the side AB, the same kind of ratio we have to take for the point Q over the side AC. Means we are free to write like this. If we are taking this PA by PB, this was for the side AB, it will be same as, you have to start with the other intersecting point QA by QC. It is not only this much, you are also free to choose the other ratio, like you may choose PA. Now in place of PB, you are also able to choose AB. PA, AB. Then on this side AC, you have to start with the intersecting point QA by AC. Or whether you are writing this as PA or AT by AB is same as, in place of QA, you may write this as AQ by AC. So both mean the same thing. Okay, it is not only this much, you are also free to choose any other ratios considering this point P. You are also able to choose, say, AB by BP. So while choosing this line or this side AB and BP, in the similar fashion we have to choose for the other side AC, then CQ. So AB by BP will be equal to AC by CQ. So these are the various possible ratios. You may write few more kind of ratios. Okay. So the important thing is that the line PQ is parallel to BC, then only these ratios can hold good. Means here, if this PQ is parallel to BC, then only these ratios can be written. The reverse is also true. If these ratios are holding good for the two side which is intersected by a line, then that line will be parallel to the third side. That is called converse of this theorem, or converse of basic proportionality theorem. Okay, so those things we will also write later. So this is the meaning. If a line is parallel to one of the side, then the ratios of the two side will be same, or the line will divide the other two side in same ratio. Same ratio means mathematically the two ratio will be equal. So this is what we have to basically prove. So what is given here? So right, for proving this, very first we have to write what is given. So the given thing is the line PQ which is drawn parallel to BC. This is the given condition. Means it can be simply written as PQ is parallel to BC. Then what is to prove? Means if this condition is holding for a triangle, then means this PQ is parallel to BC. This is holding good for a triangle. So in triangle ABC, that we have to keep in mind. Then we have to prove this AP by PB is same as AQ by QC, or this is called the standard ratio. The other derived ratio, say AB by BP, we may take AB by BP is same as AC by CQ, or even we are also able to take like this, AP by AB is equals to AP we have taken for the side AB, So therefore, on this side AC, we have to take AQ by the bigger side length, means AC. Any one of these three you have to prove, or you can prove all these three. So let us start the proving. So let us start. For bringing this ratio, we are using the concept of triangle. Okay, the area of triangle. So for that we have to do some kind of construction. So what are those construction? So here we need some construction. So before this proofing, you have to write down the construction. A student, while writing or proving this theorem, you also have to write what is given, what is to be proved, the figure that you have to draw, as I am writing everything. In the similar manner you have to write. So draw the triangle first for better understanding. Make the triangle in a different shape. Means the side length should be different. Consider this as triangle A, B, C. Take a line parallel to this BC. Here we have taken as PQ. We may write this as P and this as Q. So this PQ is parallel to BC. It is given. Whatever the construction that we have to take the triangle, area of triangle APQ. For that we need the perpendicular. Then the area of the triangle which contain the side PB. For that we need to join. This theorem is based on the area of triangle, so that we can get the ratio. So if we consider the triangle PQB with side PB, then we need its perpendicular from the Q over BP. Okay, student? For that we have to draw the perpendicular from Q over this AB. So draw the perpendicular. It is our 90 degree. So that we have to draw it carefully. It is this one. Consider this perpendicular point as M. Mark this as M. So to mark it carefully. So by taking this, what we are able to get? A student, observe it carefully. Just before writing the ratios, let me explain a bit more thing. If you have such a triangle like this, say ABC, and you want to take the perpendicular over the side AC, how you can get the perpendicular? For that you have to extend the side AC, because this perpendicular cannot fall between the AC, so this will be the perpendicular. It is like it. So that's why if we consider the triangle PQB in the figure, this QM will act as perpendicular for the side BP. Okay, a student, once again please understand the same thing what I had explained. Let me explain a bit more. Consider the triangle is like this, means it is your ABC. You have to draw the perpendicular over the side BC from A. How you can draw? It is like this. Okay, student. Now, if the triangle is like this, consider ABC, where this angle C is itself 90 degree, and from A you have to draw the perpendicular on BC, you will get this AC itself. Okay, but if this angle C is more than 90 degree, means the triangle is like this, means A, B, C. So this is the third figure. In this case, this angle is greater than 90 degree. For drawing the 90 degree, the perpendicular from A over the side BC will not lies between B and C. Rather, if you draw the perpendicular, you will observe it is going to cut the BC on extended part. So it is the M. Right? The similar thing or the similar situation is also here. It simply means if you have the triangle like this, consider the top vertex as A, the next as B, the next as C. If you are considering BC as the base and you need a perpendicular, at that time you have to extend this BC. Okay, so it is like M. The similar situation is here, where the triangle BP is drawn like this, student. Now compare with the given figure or the figure that we have taken. Our BP is like this. Understand this. B and P is like this. This is our Q. This is our BQ. Okay, the yellow in the triangle, whatever we have drawn. In this case, we are observing that this angle P is greater than 90 degree, and BP we want to take this as the base. So perpendicular height, we need to extend this, then we have to make a 90 degree over this. Okay, so it will be like our M. So this is the situation that I have drawn. Getting? So even for BP, this QM is acting as the perpendicular. Okay, student? So by taking the ratio of triangle or area of triangle APQ, so for the triangle APQ here, so if I am taking for triangle APQ, the base that we are going to consider is AP. Why? Because by considering AP, we can get the required ratio AP. So the base is like our AP, while base is our AP, then perpendicular from the other vertex means the Q vertex of triangle APB. So base is AP, then perpendicular will be your QM. So here we are observing that for this triangle APQ, the perpendicular is QM, which is falling on this side AP. At the same time, if we consider the other triangle like BQP with the side BP, we will get the perpendicular as the same. Okay, so this is important. The students are missing this point only, otherwise they will try to remember or mug up this, and this is very important theorem. It is asked very frequently. So even for triangle PQB, the base that we are going to consider is our BP, and in this case the perpendicular will again our QM. This situation is like this. So it is like this situation. Okay, student? So if I want to take the area of triangle APQ means taking the first case means triangle APQ, it will be our half. The base that we will write will be AP, and the perpendicular that we will write will be our QM. Similarly, if we are now going to write the area of triangle PQB, PQB, a student, in this case we are taking the base as BP, so half BP, but for the side BP the perpendicular is again our QM. Okay, so by taking the ratio we can observe that this QM will get cancelled and half will get cancelled. The ratio left will be AP by PB. So that situation we are going to use. Okay, so therefore what is our construction? So construction is, for getting the ratio AP by PB, we have to join Q with B and draw perpendicular from Q on AP, which is M. Similarly, for getting the ratio for the side AC, we need what? We need a triangle which shall join this Q, not Q now. Student, we need this C, so C have to be joined with P, this one, and the perpendicular from this P over the AQ. So these much are our construction. We may consider this as N. Okay, so these much are our construction that we have to keep in mind. When this BQ will be under consideration, if we are interested in taking the ratio for this side AB, this PC and PN will be under consideration if we are interested in taking the ratio for the side AC. Okay, so only this much thing you have to keep in mind. You have to take the ratio of the two triangle. Then one more concept of class 9th, the area of triangle form on same base and between the same parallel are equal. By that we can equate the area, ultimately the ratio that we will get. Okay, student, so these are the things that we are going to use. So it is very important. बच्चे ये समझते नहीं है and they try to just mug up what to write. They always caught by the same mistake that this QM and PN, how is this perpendicular? They are not understanding that concept only. Even in class 9th we have learned this thing in the chapter triangle and area of triangle itself. Okay, student, so what is the construction? So write down the construction. So join PQ or QB means from this Q of this PQ to B and draw QM perpendicular on AP. Just write in this mathematical fashion, it is enough. Okay, no need to write the big language in mathematics. In mathematics, how beautifully you are writing with the help of symbols and just picture, that is enough. Okay, so this is one part that we have to do, and this construction is marked by yellow in this figure. Also, for the other side, we need to join PC and draw from this P to N, which is perpendicular on side AC or AQ. So whether you are drawing perpendicular on AC or AQ, both mean the same thing. So only this much is the construction. Now let us continue with the proof. How is the proof? After writing this, so first we have to take this. For getting the ratios, we have to use the area of triangle. So right here, just you are able to write this. Area of triangle. Very first, observe carefully, student. We are interested for the ratio on side AB. So take the triangle formed on side AB. Means the two triangle formed over the side AB. Means at dividing point P. Means one is our APQ, another one is PBQ. So these are the two ratios that we have to take. So write area of triangle APQ divided by area of triangle PBQ. You just write this ratio. Student, I had explained area of triangle APQ can be written as half. In this case, the base will be our AP, so that we can get this ratio AP. And perpendicular, while AP is taken as the base, the Q is the other vertex. From Q, the M is perpendicular. So QM is like this one. And for the triangle PBQ, again half is there. In this case, the base that we are going to take is our PB or BP. But the perpendicular, same QM. This I had explained. Okay. And we have written this also here. So this is our one part. Here we are getting that this half getting cancelled, QM getting cancelled. It become like our AP by PB. Take this as 1. Okay. So just you draw this construction, write this ratio, it is enough. Whatever the explanation I had written, like this thing, this part, no need to write. Okay. This I had given for your understanding and your explanation. If you are missing, you can watch the videos by rewinding it. Okay, student. So this is the equation 1. Now, this way we have obtained the ratio AP by PB. Again, we are interested on the other side. On the other side, AC, the intersecting point Q, the triangle form is APQ. So we shall take the area of triangle APQ or AQP if you are in doubt. And the other with QC we are interested. So we shall write the next one as area of triangle QCP or QPC we may take. So write this as Q, C and P. Again, in this case, for triangle AQP, a student, whether you take the triangle APQ or AQP mean the same thing. Getting? But in this case, for the area of triangle APQ, we shall take PN because that will be get cancelled while we are taking the other triangle with base QC. That we have to take it carefully. So write it. Area of triangle AQP half. Now our base is, understand this, A to Q. So we shall write this as AQ. In this case, the perpendicular is PN marked by black line. So PN divided by half. Again, our base in this case is QC, so that the ratio we can get. QC into the perpendicular for this triangle QPC, where QC is taken at base, will be from the remaining vertex P over this extended part of QC, means it is our N. So it is our PN. Again we are observing PN is the same, half and half is also the same. So this can be written as, I may write here, AQ by QC. A student, here we have observed AP by PB, AQ by QC. But in left hand side, in numerator, there is area of triangle APQ or AQP, mean the same thing. But in denominator, we are getting the two triangles are different. Okay. Now, whether the area of the triangle A means area of triangle PBQ and area of triangle QCP, whether they are equal or not. If they are equal, then we can say the left hand side become equal. So that we have to observe carefully. A student, observe it carefully. So let us understand. We have to observe the area of triangle PBQ. Understand this carefully. PBQ. What is this? It is like this one. So this triangle is formed between the two parallel BC and PQ, where the base lies on PQ and the vertex lies on BC. Okay, it is one of the triangle. The other triangle is like this. Student, observe it again. The other triangle is like this. It is our this triangle. So the other triangle is like this one. So this triangle is also laying on the same base PQ and the other vertex lies on the same parallel BC. Therefore, the two triangles will have equal area. That is the only concept. So, but that we have to write. So in this case, so write here triangle PBQ, or you may write PQB, and triangle, the other triangle is our QCP, or you may write this as QPC, mean the same thing, are formed on same base. What is the same base? It is our PQ and lies between same parallel, that is, what is that parallel? BC parallel to PQ. Therefore, these two area will be equal. This is the concept of class 9. Therefore, area of triangle PBQ is same as area of triangle QCP. This is the third one. Means what? This third can be substituted in 2 or 1. It simply means that means in the third we have the triangle which are in denominator, they are also equal. So substituting 3 in 2, so right, putting 3 in 2, we get what we can get. So wherever this QCP is there, in place of this QCP, I will substitute triangle PBQ. It simply means that. So do this one. So therefore, we can write our this second one is this one, area of triangle AQP by area of triangle QCP. Triangle AQP, it was QCP, but in place of QCP, observe it once again, this area of triangle QCP, which is in denominator of 2, I am going to substitute area of triangle PBQ. PBQ is also the same as whatever we have calculated, AQ by QC. AQ by QC. Now, a student, you have to compare this one from the 4. From 1 and 4. What we are going to get? Left hand side is the same. A student, observe it. In numerator, area of triangle APQ. Also for the fourth, the area of triangle AQP or APQ mean the same. Denominator is same as area of triangle PBQ. So these two left hand can be equated, means that can be eliminated, and directly their right hand side means AP by PB can be equated to AQ by QC. So that we are going to write. So AP by PB is equals to AQ by QC. This was the proof. Thus, it is proved. So if you have to prove the BPT or basic proportionality theorem, student, you have to do this much. So this much is very important. If you are not writing this much, then your marks may be deducted. So you have to write this much. So this was the one thing or one of the ratio that we have proved here. The other ratios can also be proved. So how is this AB by BP? How is this AC by CQ? So these things we are going to prove now. So student, this theorem is very easy. You have to just take the two triangles. You have to carefully write the ratios for the left two triangle and the ratio of area for the right two triangle. The triangle that we are choosing is for the side or for the intersecting side. That way you have to take. Then you have to apply the concept that the triangle formed on the same base and between same parallel, they are equal. So this is the another important concept. So this concept means applying this while proving this carry 1 marks, means equal base carry equal area. These carry 1 marks. Writing this ratio of area of two triangle, this also carries 1 marks, and 1 marks is for this statement, and 1 marks mostly for writing the equation in other form if required. So that's why it is either asked in 3 marks or in 4 marks. So just proving this much is asked in the 3 marks. We can also prove, right? Also we can prove the other ratio like AB by BP is equals to AC by QC. This is the other ratio that we had written. See here, if you have doubt you can verify. It is this ratio I have taken. AB by BP or PB same as AC by QC or CQ. This now I am going to prove. How is this? After proving this, you have to prove this corollary. So this is called the derivative or corollary. So write, since by BPT we have just proved AP by PB is equals to AQ by QC. This we have proved by basic proportionality theorem. So this is one of the equation. If I am going to add equal on both sides, the equation remain unchanged. So what we are going to add? We are going to add 1 by BP plus 1 is equals to AQ by QC plus 1. So adding 1 on both sides is called component. So I have applied the componendo property. Subtracting 1 is called dividendo. So this componendo and dividendo you might have learned in your earlier standard like class 7 and class 8. Now you have to just simplify it. For simplification of the ratio, take PB as the common for both. So AP will remain as it is. Below this 1 means plus 1 is there. So in denominator of 1 it is nothing but 1. So therefore AP will be there. So this 1 will multiply with this PB. So PB will get added here. Again for the right hand side, the LCM become QC. Again for the first ratio it is our AQ. The next one is 1. So here this will come in QC. Now observe this. What is AP plus PB? A student, our triangle is like this. Just we have written A, B, C. This was the triangle. And here we have taken this P, Q as parallel to BC. So this AP plus PB means the two line segment and they are collinear. So they will give us AB. So left hand side numerator can be replaced by AB and denominator as it is PB. For the right hand side it is our AQ and QC. So they will get added to AC. From the figure we are writing a student by QC. So this was the second that we have to prove. So this is also proved. So this way it is proved. As students, similarly we can prove the other conditions also. So that's why any of these ratio can be used directly. So the skill is just to write the two ratios, all the possible ratios. Now taking the inverse of this, whatever we have proved, take inverse or reciprocal. Means taking the reciprocal, this PB can be written in denominator, which was in denominator. This can be written in numerator. and this AB which is in numerator, that can be bring in denominator. The same for the right hand side. So this QC will come in numerator and AC will come in denominator. So this is the other ratios that we can prove. It was this one. If we are taking the applying the dividendo or just first reverting this, means this was taking the reciprocal, we are getting this. If we are taking the reciprocal of this one, AP by PB, it's reciprocal, means inverse. Numerator will be written in denominator, denominator will be written in numerator. Means we can write PB by AP is same as QC by AQ. It is the other ratio that we can write. So all these are the possible ratios what we can write. Even we apply the componendo in this case, then we will get the new ratio, the same, whatever required. PB by AP adding 1. So this is the trick or skill that we have to keep in mind. For adjusting this ratio, we have to apply the componendo, either first by taking the reciprocal, then adding 1 on both sides, or first adding 1 on both sides, then taking the reciprocal as it is required. So adding 1 for the left hand side, we are able to get PB plus AP is equals to, again AQ will be in denominator, QC plus AQ. Observe again this carefully. A student, numerator is PB plus AP. Observe this figure. PB means this one plus our AP, this one, same as AB. So here we may write this as AB by AP is equals to QC plus QA. Observe on the other side. This is now our QC means this much and QA is this much. So again it is going to give us AC or CA. Right, in convenient manner like AC by, here in this case we are getting this as AQ. So it is the other ratio that we can write. So this way all the possible ratios can be written. Taking the reciprocal of this, we may keep this AP in numerator by AB in denominator and AQ in numerator and AC in denominator. So it is the other ratio. So student, while you have to prove the other derived ratios, you have to just apply either first taking the inverse, then adding, or first adding, then taking the reciprocal. So this way we are getting all the possible ratios. I have derived it. Okay. So the concept is very simple, just adding, taking the reciprocal, or first take the reciprocal, then add, whatever required accordingly. Means our purpose is to get AB. If we have AP by PB, so whether in numerator is required or in denominator is required, accordingly we have to adjust. Means first we shall take for the inverse, then adding it, or first we shall add 1 means componendo, then we shall take the reciprocal. So this was all about the basic proportionality theorem. A student, there is reciprocal of this. The reciprocal is called inverse of or converse of this BPT. So let me just write it here rather than explaining more. Converse of BPT. This converse is nothing but just opposite. Means what was given condition in BPT? What was the given condition? The given condition was if a line is drawn parallel. This was the given condition. And what was to be proved? The ratio is same. Now for converse, the ratio will be given to you, and whatever the parallel, that we have to prove. Means they are just interchanging their position. So this converse theorem will be nothing but, it is simply, if the ratio of the two sides by an intersecting line is the same, then that line or that point will be parallel to the third side. It simply means that. So right, if the ratio, or we may copy and paste directly from our textbook, if the ratio of intersecting point on two sides are same, then the line joining the intersecting point will be parallel to the third side. So write it properly. So the two sides are given, the remaining side is called as the third side. So how is this? We may see. Though we have taken the question here. So let me go on next page. So what is given in this case? The given is like this. The ratio is already given to you. You are given with triangle ABC, in which the point P and Q are the 2 points on the two sides, such that the ratio of AP by PB is same as AQ by QC. Then it will be proved, or it can be proved, that the line joining this PQ means this one, means PQ, this will be parallel to BC. So just you have to keep in mind, if the ratio is given, it means the line joining this PQ will be parallel to the third side. This was our first side, the two sides that we have considered. This is our second side, for which the first two sides the ratio is considered, and this is our third side. So the line joining the intersecting point is parallel to the third side. Okay, it was this one. So only this much explanation is enough. So it may be asked in MCQs, the question based on this. So check in which of the cases, write down a question. Check in which case the intersecting point will give a parallel line to the third side. In MCQ, the question may be framed. So let me take some question. In the first condition, we have considered this as PQR, and M and N are the 2 points, such that there is 2 and this much is our, say, 8. Consider this as consider now this as the 1 and this as this much length as our 3. Okay, this we have to check. The second one, take one more question. One I will explain and the other you have to do. Take one more. Consider this A, B and C. Another ratio is like this, or it may be given itself. So take it. Consider this as P and Q. Okay, only this much, and even third one more I will take. Consider this as the 3, this is 2, this is 6, this is 10. This one we have to verify. The third one, so trapezium like thing is given, where this is our A, B, C is there, C and D, such that I may take this as P and Q. Consider this as 2, 3, and this is 1 and 1.5. We have to check which of these are parallel. Student, so how to verify? See, for applying the condition, we have to check for if we are considering QM by QP. So just at least in one of the numerator or denominator, you must include this intersecting point M and make a ratio. You may include at both numerator and denominator also, it is up to you. So if we are choosing this one, QM by QP, see, starting from the Q going to M, then starting from the Q we are going to P. So here on the other side we shall take QN then QR. So we need QN and QR then parallel. If this is the condition, then MN will be parallel to our PR. This is the condition. Now we have to check whether QM by QP is equals to QN by QR or not. So calculate this. Here QM by QP. What is this? Already given 2 by 8 is there, it is like our 1 by 4. It's 1. Also, take the other ratio, which is our Qn by Qr. The bigger length we have taken in denominator. So write this. Qn is given as 1. But Qr, for that we need to add 3 in this 1. Because the length Qn is 1 and Nr is 3. Here again we are getting 1 by 4. So therefore, here we can say this Mn is parallel to our, the remaining side is our PR. So this way you can verify whether they are parallel or not. Here also we are getting that. So even you are free to choose by the other way also, like this is 10, this is 6, so this will come as 4. Now taking the ratio, here it is 3 by 2, here 6 by 4, means again you can cancel the 2, it is like our 3 by 2, means this also tells that PQ is parallel to our AB. Okay, it is this much. Coming to the third one, though it is not forming a triangle, but still this basic proportionality theorem is applicable. How? You can imagine that if you are going to extend this side, they are going to form a triangle. Okay? So this way you have to just understand. Means whether this triangle is completed or not, that doesn't matter. But the ratio of this side we have to check. Means this basic proportionality theorem is also applicable for trapezium conditions. So this is a notable difference on which the question are framed. So again you have to take the ratio, whether you are going to take this bigger ratio with respect to P or with respect to A, that doesn't matter, or whether you are just taking AP by PC, this is our 2 by 3, and again on the other side you need to take the ratio. Here we have started with the A, corresponding to A in this triangle, it is our B. So we have to start with B, corresponding to P, it is our Q. So PQ means B to Q, then again Q. We have to start because on the left hand side we are taking the PC. So it will be QD. QD. Take this 1 by 1.5. Again you are getting the same thing or not. So you have to put a 10 in numerator and 15 in denominator. You may cancel with the 5, 2s are 10, 5 3s are 15. You are able to get 2 by 3. So in this case, also our PQ is parallel to our CD. Okay, it is this one. Here it is given that this AB is parallel to BC. This will be already given. So this is a trapezium basically. So these are the conditions how the questions are framed. So ये आपको ध्यान में रखने हैं कि how the questions are framed and how to apply this basic proportionality theorem and converse of that. Only this much is enough for this topic. Now let us go for the basic proportionality theorem. So here in this case, AB DC is a trapezium. Then we were searching whether PQ is parallel to CD or not. So this PQ is parallel to CD and CD is also parallel to AB, means PQ is also parallel to AB. So all the three are parallel. So this way, by knowing the ratios, we can say whether it is parallel or not. And if it is the parallel, then their ratios can also be calculated. Let me take that kind of question also. Or that kind of question is already in your book. Let me just copy it. So let us try this. A student, the question number 2 I had already explained in earlier sessions, but just for your understanding, we can check for any one of this, or even we can skip it also. So I'm going to give the hint here itself for the 2. A student, for understanding, means whether for checking whether this EF is parallel to EF, market. EF, E and F are the point on the side PQ, PQ and QR. This is not the figure for this one. Yes, it is not the figure. The figure is given for this, not given. So draw it. Don't worry for this question number 2. So let me draw the figure for the question number 2. E and F are the point on side PQ and PR. So PQ and PR. So take this as PQ and PR. It is given that E is a point on PQ and F is a point on PR. F is a point on PR, respectively, or triangle PQR. Then for each of the following case, whether EF is parallel to, you have to check for whether EF is parallel to QR or not. Same as whatever I had taken. Okay, the same kind of question. So just plot this point, take the ratio. So for first I'm going to check it. Put this. PE is equals to 3.9. PE. So put it properly. It is our 3.9. EQ. EQ is our 3. PF. PF is our 3.6. And FR is our 2.4. Okay, it is given like this. So you just take the ratio. What ratio we have to take? So just taking the ratios for the two side. So take this PE by EQ. PE by EQ. This ratio I am going to take. 3.9 by 3. So 3 ones are 3. 3 3s are 9. 1.3. For the other side, write the ratio. PF by FR. Take 3.6 by 2.4. Cancel. The decimal can be removed, means it's simply 36 by 24. So 6, 4s, and then 6, 6s, or even 8 is also common. So 2, and it is our 3. So it is like our 3 by 2. It is like our 1.5. So what we are getting? Here, the two ratio, one ratio we have calculated this, other ratio we have calculated this. These two are not the same. So here, PE by EQ is not equals to PF by FR. Therefore, this EF is not parallel to QR. Are you getting? So this is also based on our converse of BPT. Okay. Similarly, you can check for the other second and third condition. So this way you can solve it. So this was the solution for our question number 2. Now let me go for the question number 3. So in question number 3, the figure 6.18 is useful for us. So this we have to take. So in this figure, we have to prove this condition. So right. Solution to the question number 3 that we are taking. So let me redraw the figure. Figure is already given. So I'm just redrawing it. Let me reduce the length. Let us mark it. The point are like our A. This between A and B there is M. The other on horizontal is our C. Between A and C is L, N, and D. So this is the figure given, and here we have to prove this ratio. So in this case, what is given, that is to be written first. So what is given? The given condition you have to write. So given, you are able to observe from the question itself. LM parallel to CB and LN parallel to CD. So right, given LM parallel to CB and LN parallel to CD. These two parallel conditions are given. A student, recall the BPT. If there is a triangle, it means we can recall for the BPT exclusively wherever a parallel line is drawn which is intersecting the two other sides. Here we are observing that if we consider the triangle ABC, in this case LM will be parallel to BC. Also, if we consider the triangle ACD, then LN will be parallel to CD. Means for this parallel condition, we can write the ratio. So right, what is to prove? To prove, so to prove is AM by AB is equals to AN by AD. This is to prove. Okay. So no need of any construction here. The given condition itself is sufficient. So let us start proving it. So whenever parallel line is given in a triangle, means a ratio is given. So right here, in triangle, consider ACB. How I have decided this ACB? So whatever one given condition is there, by observing that we have to choose the triangle. Okay, so concept is very simple. So that's why we have taken this triangle first or written this triangle first. So in triangle ACB, LM is parallel to CB. This means wherever parallel is there in a triangle, we can write the ratio. This means we can start with AL by LC, that we can write, or even AL by AC we can write. So whatever required, you observe that ratio, then you find it. So here we are getting in this triangle ACB or ABC, just observe this much. We have AM, means this much is required, by AB, this much AB is required. So better to choose the ratio directly. AM by AB is equals to AL by AC. Okay, that will be sufficient. So this thing we have to develop. So right directly we can write, because all the derived ratios can also be used directly, or many a time you may write AM by MB is equals to AL by LC, then adding one you will get the same derived ratio. So you are free to choose the required ratio. So write directly AM by AB is equals to AL by AC. You have to take this as one. So one of the parallel condition is used. Now we have to go for the other. Also, so this is over, and one ratios we have written. Now let us go for the other. Ln parallel to CD. So where is this Ln parallel to CD? What are the conditions where I can use this parallel? So Ln parallel to CD means it is in this triangle, where this is parallel to this one, means I can write the ratio like AN by ND or AN by AD is equals to AL by AC, means whatever the required ratios, that can be written. So just by observing what is given, what ratios can be written, you have to apply that much only. By that you can reach to the result. Okay, student. So now let us go for the next one. So here in triangle ACD, again in this case the condition like Ln parallel to CD is available to us. Now from this, which ratio I shall write? So I shall write that ratio which can correlate the ratios that I have written earlier with the other given condition. So there we have written AM by AB is equals to AL by AC. So here even we can take this AL by AC same as AN by AD. This we can write. This way AL by AC will act as the intermediaries, and that can be removed by equating the two equations. So just write it. AL by AC is equals to AN by AD. Okay. So this is the ratio 2. Now from 1 and 2 what we can say? Just observe this. From 1 and 2 we are observing that the two, this ratio and this ratios are equal, therefore these two will also be equal. So right from 1 and 2 directly we can write AM by AB, or just equating 1 and 2 we can write, okay, because one of the side is this n is equals to AN by AD. Just it is proved. So very quickly you can write it. So directly, whether the standard one means in between or derived, both of these can be used. So questions are very simple. You have to just take care how to take the ratios. Here we are observing that the ratio AL by AC is acting as the intermediaries, which is used for equating the other two ratios AM by AB with AN by AD. Okay, so this way it is equated. So based on this concept, other questions are framed. The same is also in this question number 4. So let me explain the question number 4 also. Okay, so let us take this question number 4. Sorry. Yes. Now let us go for this question number 4. So in this question number 4, again the concept of question number 3 is also applicable here. Let me redraw the figure. A student, keep in mind, in your examination you also have to draw the figure in your notebook. Drawing the figure carries marks. If you are not drawing the figure in your answer book, though you are writing all the things correctly, you will not get the full marks. Some of your marks will be deducted. So drawing the figure, writing what is given, what is to be proved, these things are carrying marks. So nearly 1/2 marks is carried for drawing the figure and writing what is given and what is to be proved. So just to redraw the figure, let me redraw this figure. Okay, slightly tilted one. So let me also correct it. Consider this as B, A, C, this is E. From this E, let me draw a line parallel to this one, and from this I have to draw a line parallel to this one. Our D, this is our F. So the figure is like this. What is given? Write down it. The given is DE is parallel to AC and DF is parallel to A. These things are given. Better habit is to mark this in the figure itself. D is parallel to AC. Where is our DE? Observe it. DE, it is this one. It is parallel to AC. Just by putting this mark, you can understand which triangle I shall consider. The next one is our DF. Means if I'm going to consider this DF, I shall take AE. Means I shall take the triangle BAE. Okay, so this way just marking on the figure also assists you. And what is to be proved? Then we have to prove BF by FE is equals to BE by EC. A student, what is to be proved? First you shall understand what is to be proved in the figure itself. Then you shall understand what could be the intermediate ratio that can be eliminated? So BF, sorry, yes, B, start with B, go for F. So BF, it is this one. Then FE, it is this one. Understand this. How I can get this BF and FE? This can be obtained from the triangle BEA. It is this triangle. Okay. The other ratio that I need to be equated is BE. So mark it, BE is our this one by EC. Now I need this one. Okay. How this BE by EC can be obtained? By taking the triangle BCA, in which ED is parallel to AC. So this way we are observing that this side BA is acting as intermediate, in which BD by DA ratio can be taken and that can be eliminated. So this way you can just observe the figure and you can prove it. That you have to write it. So let us continue. Solution. So take this. DE parallel to AC. In which triangle is this? And what ratio which is to be proved or which is to be proven, that can be written from this. That is the only idea that you have to keep in mind while writing this mathematics. So write DE is parallel to AC. So take the bigger ratio or bigger triangle. While DE is parallel to AC, I need to take the triangle BCA or ABC. But better habit is you just start with the common vertex B, C and A, and in that we can write in triangle BCA. Here we can write the parallel side is our ED or DE is parallel to our AC. So while DE is parallel to AC, we can write the ratio this implies. So observe this. A student, DE. So come to this point E here, and on the other side the point D here. So for a moment you shall forget the other line like this one. Let me just erase it. So it is something like this. Okay, it is something like this, where ED or D is parallel to AC. So from here we can write the ratio like BD by DA is equals to BE by EC, or BA by AD is equals to BC by CE. But which ratio I shall write? Again, for that you shall take the help of to prove, in which ratio is to be proven. So here we are getting the E is related to the right hand side, means this side. So we have to take BE. So start with that one itself. BE by EC. So BE by EC, here we have taken for this side BC. So on the side AB, the same ratio means BD by DA have to be taken. Take this as 1. It's enough. By this way, one of the condition means parallel condition and one of the ratio that we have written. The same thing we have to do for the other parallel condition which is given, and the other ratio we have to write with the help of intermediate side AB we have introduced here. So let me draw the other, the other figure or the part that I have just erased. Okay, student. So this part is now required. So write it. In triangle, so take the other given condition. DF parallel to AE. DF, mark it. DF in this figure, parallel to AE. Parallel to AE. Mark in this figure. Means here we are observing that we can use the triangle BEA, which is marked in yellow. So triangle B, E and A. Means now we are interested with the triangle BEA. In this triangle, this DF is parallel to AE. So this way, by understanding the given parallel condition, we have written the triangle first. Okay. Now by observing this parallel condition, we can write the ratio. So write the ratio. If you have any doubt, for a moment you may erase that the other unwanted side, or you may hide that unwanted side. What are the unwanted side? These are the side that is going to create us confusion. So I have just eliminated. Observe the figure. How is this? So again we are observing that this DF is parallel to AE, so I can write the ratio. Which ratio I shall choose? Whatever given in the question. Means I can choose this BF by FE will be same as for the other side, other intersecting side, it is our BD by DA we need to take. Is it okay? Now observe this. Now after writing this, the story of figure is almost over. Now we have to observe the ratios that we have written. What we have? We have introduced the intermediate ratio BD by DA. BD by DA. These two are the intermediate ratios. Means right hand side of the two equation are the same. So left hand side can be equated. So right from 1 and 2, what we can get? Directly you can write the ratios. So once you have written the ratios, directly you can equate and write it. BE by EC is equals to BF by FA. This was to be proved. Whether BF by FE is written on right hand side or left hand side, that doesn't matter. So this way it is proved. So student, concept is very simple. You have to introduce the intermediate size and intermediate ratios for that side, and you have to equate it and eliminate it. So this was, so wherever the parallel condition is given, the ratio can be written in term of some intermediate side, and that intermediate side have to be eliminated. This way we can reach to a result. So this was all about this. Let me take one more question. The same concept is also applicable for this figure 6.20 where you have to choose the parallel sides properly, and after that you have to equate it. The same concept everywhere. Student, you please try this. Next day we will continue with this, and yes, it is more than 10 o'clock, so we shall stop it. We will continue with this, and we will do the other theorem also. So we need 2 more classes to finish this chapter. So you please do this as the homework. Regarding this trapezium, you will try. If required, next day I will explain this question number 10 also. Question number 10 is very important. It is asked very frequently. So whatever the concept I was explaining, this concept in the question number 3, the same concept is there. So this way you please do all the question of exercise, write down the homework. Our exercise 6.2, all questions. So up to end you have to do it. Okay, please do this much, and please do the frequent revision of your topics. Otherwise आप भूल जाते हैं, marks अच्छे नहीं आ पाते हैं. So please do this. And you people are appearing for NTSE. तो NTSE के लिए अभी आप जरा रीड करिए. इसके जितने भी आपके सीरीज के क्वेश्चन है या एनालॉजी के क्वेश्चन है, आपके जो एक्सप्लोरर के क्वेश्चन है, एटलीस्ट उसे तो फिनिश कर ही लीजिए. इसके अलावा भी और भी यदि कोई प्रीवियस ईयर क्वेश्चन देखते हैं तो उससे भी अभी आप रेंडमली ट्राई करिए. डू नॉट ऑलवेज थिंक कि सारे के सारे चैप्टर फिनिश होने के बाद आप क्वेश्चन अटेम्प्ट करेंगे. आई विल शेयर सम ऑफ द क्वेश्चन पेपर. आप उसमें से सीरीज के क्वेश्चन ढूंढ करके आप खुद से ट्राई करिए. एंड हमने सीरीज एंड एनालॉजी इतने डिटेल में पढ़े हैं कि आपसे सारे के सारे क्वेश्चन हो जाएंगे. So please do this much. This much is enough for you people. Yes, student, any doubt then please ask.